Hello! Okay, so today we're going to be learning about organic chemistry, specifically how to name basic organic compounds. Okay, let's start with some basic definitions. Organic chemistry is the study of organic compounds, and organic compounds are any chemical compound that contain carbon. So examples of this would be things like methane and sugar. However, there are some chemical compounds that contain carbon that aren't organic compounds, so those would be exceptions to the definition. These exceptions include oxides of carbon, carbides, carbonates, and cyanides. Okay, so now let's move on to how we can represent these organic compounds. The first way we can is through the empirical molecular formula. So this is the formula that just tells you exactly which elements are in this compound and how many. So for example, C2H6 is the empirical molecular formula for ethane. Another way that we can represent these compounds is through their structural formula. Now this one is the most annoying to draw because it's so tedious, but it's really helpful in naming organic compounds because you can see exactly where each element is and the bonds between the elements. But frankly, I'm honestly usually too lazy to draw the full structural formula, so I'll use the condensed version instead. So for this one, you might remember in grade 11 we learned that a carbon has 4 spaces on its outer rings for other elements to bond to. And since, as we can see in this example, the carbon is already bonded to another carbon, it has 3 empty spots left for hydrogens to bond to it. So we would just write the hydrogens right beside the carbon instead of drawing them out with their bonds. And then finally, the easiest way to represent an organic compound, but kind of the hardest one to decipher, is the line formula. So you essentially just draw a line representing each bond, and the end of the line or a bend in the line represents a carbon. In this case, since we're representing ethane, which only has 2 carbons, it's literally just a straight line. But if we were to do something like propane, which has 3 carbons, it would look a little bit more complicated. And by more complicated, I mean there's one bend in the line. So as you can see here, the ends of the line represent a carbon each, as well as the bend in the middle, making it 3 carbons, which is the right amount for propane. Okay, so let's try one. Let's try to draw heptane in all of these different formulas. So heptane, the molecular formula would be C7H16 because it has 7 carbons and 16 hydrogens. So if we're trying to draw it with the structural formula, we would first draw 7 carbons, all connected by a single bond, and then draw our hydrogens around it. Remember that hydrogens can only have one single bond. You can't have them do a double bond because they only have one empty place in their outer ring. So your structural formula would look like this. And if we go over it again, there are 16 hydrogens and 7 carbons, meaning that we drew this correctly. Moving on to the condensed structural formula, we would essentially just draw this again, except not draw out the hydrogens. We just say CH3 connected to a CH2 connected to a CH2, etc. until we have 7 carbons. And if we go over this again and count the carbons and hydrogens, we have 7 carbons and 16 hydrogens. So we're right again, woo! Now finally, let's try drawing the line formula. So you would just count 5 bends in the line plus the 2 ends of the line, with each of these representing a carbon. So you have 7 carbons. Once again, we are correct again. Look at us go. Woo, we love chemistry. However, what would we do if we don't have the name for this compound and all we have is the diagram? How exactly would we name this organic compound? There are a couple different steps for naming an organic compound. First and foremost, we need to find the parent chain of the compound. The parent chain is the longest continuous chain of carbons in the compound. So for our example up top, it'd be pretty easy because there's only one long continuous chain of carbons. However, if you're looking at something a little bit more complicated that has branches, like this example here, you would have to find the parent chain by finding the longest continuous chain of carbons. So it would be these 4 up here. It would not be these 3 because 4 is a longer chain than 3. However, for the sake of simplicity, the example we're doing up here, our parent chain is just the whole compound. So, once you have found the parent chain, you need to count the number of carbons that are in this chain. So if we go up to our example, there are 1, 2, 3, 4, 5, 6, 7 carbons. Now we're going to use this number to find the root name of our compound. So essentially, depending on the number of carbons, it will correspond to a different root name. I'm going to draw you a table up here, and I suggest that you copy it down and keep it somewhere you can see for when you're doing questions about naming organic compounds. I'm going to make a table. Please make yours prettier than mine because, wow, those lines are not straight, but you get the idea. So if we're going to use this to name our example up top, there are 7 carbons, meaning that the root name for this compound is hept. However, we are not done yet. We still have to find the suffix for this compound. So in order to find the suffix, we need to use the type of bond that is in this compound. If you guys recall from grade 11, there are 3 types of bonds you can have. You can have single bonds, double bonds, or triple bonds. As you can see up here in the example, these are where the bonds are in the diagram. I'm going to draw you guys another table because I have no creativity. So, if the compound you're naming has only single bonds, the suffix for this is ane, ane. So an example of this would be C2H6. So if we draw out the diagram for it, we have 2 carbons and 6 hydrogens, meaning that there are only single bonds in this compound. We know that the root name for this is eth because there are 2 carbons. So because there are only single bonds, our suffix is ane and the compound is ethane. For compounds that include any number of double bonds, the suffix is ene. So an example of this would be C2H4. Because there are only 4 hydrogens to fill up the empty spots on the carbon, we need to have a double bond between the 2 carbons. And once again, there are 2 carbons, the root name is eth, and the suffix is ene because there's a double bond there. Finally, for triple bonds, the suffix is yne, ine. So for C2H2, we have to have a triple bond between the 2 carbons to make up for the fact that there are only 2 hydrogens we can use. And once again, there's 2 carbons, so our name is ethine. So if we go back to our original example, we can see that there are only single bonds in this compound. Therefore, the suffix is ane. So if we add it on to the root name that we found before, we get heptane. Therefore, this organic compound's name is heptane. Of course, it gets a lot more complicated when you start adding stuff like branches and carboxylic acids and stuff, but that's for another day. Thanks for watching!